try to put this together. There's our first part. And the second part. Big old brackets. Then this conclusion, not Q. And there it is, just written a little bit more neatly. And what I want to do now is a truth table to verify this, to see if it is valid or invalid. So let's go through here and fill in all of our simple letters. TTFF, TF, TF. Not P says look at this and change them around, negate them. Not Q says look at this column and negate those. False, true, false, true. So now let's start doing some work. If P, then Q. The only time the conditional is false is if the premise is true and the conclusion is false. So this is false. The rest of these will be true. That is my answer for that first parenthesis. I need to put that together with this using and. So the only time an and statement is true is if both simple statements are true. So true and true is true. True and true is true. These other guys are false. That is my answer for that whole bracket part. That has to go together now with that, using the conditional. The only time the conditional is false is if the premise is true and the conclusion is false. So, is it valid or not? For it to be valid, this whole column better be all true, so it is invalid. And the other reason it is invalid is that this is the fallacy of the inverse. If P then Q, not P does not necessarily mean not Q. Okay, use the truth table to determine whether it is valid or not. So here's our vertical arithmetic. We need to put this together. Now how are we going to put this together? We're going to take all of this in the first parentheses and all of this in the second parentheses. Big old bracket. And the reason the big old brackets go there because I've got a line right there that stops me. Remember the three dots is the same as the arrow here. Q, then P. So that's the same thing written again, just a little more neatly, along with all the T's and the F's. Remember, it's your choice on these if you want to write those in. Maybe for just P and Q, you have that memorized. Maybe for P, Q, and R, it's a good idea to have it in front of you. So whatever works for you. I'm still going to do this the same way. I'm going to go through here and fill in any of my plain old letters. And the nice thing about this is it's in front of me. So I know P for this has to be T, 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 followed by 4 F's. My R is this column, which is T, F, T, F. R, I just did, T, F, T, F, T, F, T, F. Q, my middle column, T, T, F, F, T, T, F, F. Do you, at this point, need to have this written down in front of you, or do you have it memorized how the T's and F's go for your P, Q, and R? Your choice. If you need to write it, write it. If not, then do it out of your head. Still filling in the plain old letters. Q must go T, T, F, F, T, T, F, F. And we're back to P. P we know has 4 T's, followed by 4 F's. Okay, now I'm going to work within the parentheses. In my first parentheses, I'm doing the conditional, and the only time the conditional is false is if the premise is true and the consequent is false. So this is false. Let's see, do I have any more of those? Yep, right there. The rest of these will be true. Same idea on the conditional here. We're looking at if R then Q. The conditional is false only if the premise is true and the conclusion is false. Any more of those? Yep, right there. So the rest of these are true. Now these two red ones are going together with and. The only time an and statement is true is if both are true. Now here's just a reminder what I said before. If you're doing this on paper and you think you're looking at too much stuff, the different colors can be very helpful. And the other thing is you could lay down a piece of paper or a pencil or something on these that you don't need to look at. I could right now, I guess, just erase those and get them out of the field of vision. I just don't want to. So now back to I'm doing and. The only time an and statement is true is if both simple statements are true. So I'm just looking at the reds. So T and T is true. The next place I have that is here, here, and here. So the rest of that column is false. So all I need is this column right here. That is my answer column for all of that. Then let's work over here. So the conditional on if Q then P, the only time the conditional is false is if the premise is true and the consequent is false. I have that in those two places. The rest of these are true. Circle that up just to help you remember that that's the answer column for that part. I have to put together now this black column, which was the final column for that big bracketed part, with this part right here, which is the answer column for this conditional. So putting those together under the conditional, the only time the conditional is false is if the premise is true and the conclusion is false. Premise is true, conclusion is false, which means the rest of these are true. That is my final answer column. Is it a tautology? No. Therefore, it is not valid, which your choice will be invalid. There's a little bit more involved here because we need to decide on what P and Q are and then be able to put this together. So I'm saying P is you ate salad, Q is you lost weight. Now let's see if we can put this together and make the argument. You ate salad, which is P, or you lost weight, which is Q. So what we're looking at is P or Q. This says you did not lose weight. That's a negation of Q, so this is not Q. And then therefore, last year you ate salad, which is P. So do we see that anywhere? And it's right here. To determine valid or invalid, we're going to have to take this and write it together as one whole compound statement. And how do we do that? We take the first part and we put it in parentheses, P or Q, and the next one, which is not Q, put all of that in a big old bracket, then our conclusion, which is P. So I have that typed up more neatly right here. And then we're going to do our truth table on this. P is T, T, F, F. Q is T, F, T, F. Not Q is a negation of this, which is false, true, true. And P is T, T, F, F. Then we'll put those things together. Or, the only time an or statement is false is if both are false. So this is false, the rest of these are true. This is my answer column for that first parenthesis. We're putting that together with this using and. And the only time an and statement is true is if both simple statements are true. So true, true would be true. The rest of those will be false. That is my answer column for the big bracket. The big bracket has to go together with this column, and we're doing the conditional. So the conditional, the only time the conditional is false is if the premise is true and the conclusion is false. Well, I don't have that situation. That means all of these must be true, and if all of them are true, it's a tautology, and we are looking at a valid argument. Similar problem. This time we have our P and Q identified for us, so we just need to use our P and Q and go back and translate this to symbols. he goes to class was P, or he will do well was Q. So this is P or Q. The next thing says he will do poorly. Well, doing poorly is the opposite of doing well, so this is not Q. And then therefore he goes to class, which was RP. So that's just written a little bit more neatly. Let's put this together into our statement here. We're taking the first, P or Q, and the next, and then P. We just have to do our truth table to determine if it's valid or not. So P is TT, FF, Q is TF, TF, not Q, FT, FT, and then P is T, T, F. F, start putting together. For or, the only time or is false is if both simple statements are false. So the rest of these are true. This is my answer column for the first parenthesis. Put that together with this using the connective and. The only time and is true is if both simple statements are true. So right here, TT gives me a T. The rest of these are false. So now my answer column for the whole bracket must go together with this using the conditional. So I'm only looking at this and this. Put it in a little same colored box if that helps you. And the only time the conditional is false is if the premise is true and the conclusion is false. I don't have that, so all of this is true. So notice how they've done this answer-wise. It says the argument is valid, and then it expects you to write the symbolic form. And the reason they do this is so that you don't just guess valid and invalid. So you're going to say it is valid. And the argument is, this is your argument right there. This is what you would type into the box for the argument. That's what they mean by argument.